Hi, everyone. I'd like to talk to you about 7 factors that are driving the AI revolution. The first one is capital. Capital is now rushing into the AI space. In fact, the deal activity in 2016, in the first quarter, was up 7 times deal activity in the first quarter of 2011. And in fact, if you look further, you've got $2.3 billion invested in 2015, and it's accelerating. You can look at the deal acquisition forest. This is not intended as an eye chart. It's just to give you some pattern recognition on how rapid these deals are, largely large companies gobbling up small startups in AI. People often ask for formal definitions of AI. I don't think they're that relevant, but pattern recognition techniques to solve practical business and technical application problems, software agents that, when given a set of resources, can use those resources very efficiently to solve a specific set of objectives, a vision of superhuman intelligence that really hasn't happened yet, and computer science that's accelerating all of the other exponential technologies that you'll be hearing about at this summit. From synthetic biology to medicine, robotics, nanotechnology, all of them are really being enhanced and accelerated by AI. And AI is, in fact, a subset of computer science. Deep learning is a subset of machine learning, and machine learning itself is a subset of AI. The algorithms and the hardware get all the press, but in fact, what we're seeing now is an emerging synthesis, a symbiosis of machine intelligence and human intelligence. And when you look at the back room of any AI startup, what you'll see is a combination of human intelligence interacting with machine intelligence to create very powerful problem-solving systems. The second big factor driving the AI revolution is algorithms. Deep learning is the champion algorithm in machine learning. It's been winning all the relevant contests. You can look at how it works as a set of hierarchical pattern recognition stages. At the first stage, if you're looking at some pixels from an image, it can extract edges, horizontal lines, vertical lines, diagonal lines. At the second stage, object parts like ears, noses, eyes, mouth. And at the third stage, objects like faces. That's just a 3-stage pattern recognition hierarchy, and Microsoft has demonstrated a 150-stage hierarchy that has much greater feature recognition and fidelity. One of the things that you can do with AI algorithms is use them yourself. You can download the R toolkit onto your laptop. It's free, and you can use RStudio, which is a graphical programming environment that tames R. It's a little bit like Unix to program. It's not particularly friendly. You can use the graphical programming environment to make it a lot more friendly. RStudio, it comes in a freemium version and a premium version. And you can also use a service now on the web, fairly recent, a service called Sentient. They've had a lot of investment. This came out of a lot of work on deep learning and genetic algorithms. They're into scaling solutions. For example, recommendation engines, where they start with a set of random solutions for recommendation engines. They run them across training data. They rank them. They take the top 5%. They allow the top 5% to exchange some of their weightings in their algorithms, and they go through the training again and again and again, thousands of times, until they end up with very high resolution, high fidelity recommendation engines. Let's look at hardware. This is a TPU that was just revealed by Alphabet. This is a tensor processing unit. It has a computational efficiency about 10 times what Alphabet was using previously. The computational efficiency per watt is a very big deal if you're doing lots and lots of computation. This system can fit into the standard data racks at Alphabet, and they're using them and have used them for the past year in Search and Street View and also some famous game competitions. Qualcomm also has a deep learning chip that's a specialized device, and it can not only run deep learning in its native form, but it can also do 4K video processing, and it can do DSP, digital signal processing. This chip is finding its way onto a variety of mobile devices. And here we have NVIDIA, which has its own deep learning chip, and they have already tested it in an automotive environment for self-driving cars. IBM has its own specialized hardware. It's the True North neuromorphic computing platform. This came out of a DARPA-sponsored Synapse program. It was headed up by Dharmendra Mota at IBM Almaden. This array of 16 processing chips has 16 million neurons, 4 billion synapses, and it only uses 2.5 watts of power. It's an extremely low-power device, and it's now available on a single board configuration. Data is another driving factor in the AI revolution. We have all kinds of data all over the web, from Wikipedia and relational databases, dark web information, news topics, medical topics, genomic data, market price data. All of that data can be fed into a hierarchy of algorithmic engines like those that you can find at Dataminer, a company that has over $130 million worth of investment. And they can spew out vectors of information that are highly relevant for particular classes of users, like people who are interested in news or market data or health data or the public sector. Now we're seeing the integration of algorithms and data. Alphabet has released TensorFlow, which is a software library for machine intelligence. This is a system that operates on a data flow architecture, and the nodes in the data flow architecture are algorithms. The edges are multidimensional data arrays, and this allows Alphabet to distribute this algorithm and the data across wide fabric of distributed computing like the TPUs that I showed you earlier. This system is now available for free, and you can run it on a variety of different platforms. It doesn't have to be TPUs. Yet another factor driving the AI revolution is talent. Apple has acquired the machine learning startup Turi fairly recently, and they acquired them partly because Turi had some very good software for tuning up machine learning algorithms at scale. But they also acquired them because they wanted the talent in this company. Likewise, when Intel bought up Nirvana, they did it partly because they wanted the cloud-based machine learning solutions that Nirvana had, and they also wanted the talent in that company. Baidu recruited Andy Ning to be part of their team, to be their chief scientist, and just 4 days ago, Baidu announced with Stanford and the University of Washington a competition between humans typing to do texting and a deep speech 2 system that was developed at Baidu. And it turned out that the speech-to-text system from deep speech 2 was 3 times faster and 20% more accurate than humans typing text on their own. And these were digital natives doing the texting. The Mandarin Chinese result was about, I believe it was 2.8 times faster and 63% more accurate. So it's both English, Mandarin Chinese, and soon other languages. Facebook has recruited Jan LeCun, who was at New York University, and Jan is an expert in convolutional neural networks. And Facebook announced in 2014 that they had developed a deep face system that could recognize human faces with near human accuracy. There's now a deep face 2 that has exceeded human accuracy. And just a few weeks ago, Facebook announced a deep text system that could recognize what people are saying in their Facebook posts and recommend products and services to them. So if someone said, I just got out of a taxi, it would recognize that that's a different statement than I need an Uber or I need a ride. So this system has enormous power to provide recommendations in real time to people on their mobile devices. Google, now Alphabet, acquired an AI company in the UK called DeepMind for more than $500 million in January of 2014. And a lot of people thought, what's that all about? They didn't even have a product in the marketplace or a service. But what it was about was a really extraordinary and seminal demo that had occurred in December of 2013, where the DeepMind team had built an Atari game player that combined a convolutional neural network, which is a fancy word for a pattern recognizer, a very powerful one, with reinforcement learning, which reinforced that pattern recognition agent for a high score in 7 arbitrary Atari 2600 games. The system started out with zero knowledge of these games, didn't know the controllers or the characters or anything, and it outperformed all previous approaches on 6 of the 7 games and outperformed human experts on 3 of them. It's now been applied to over 60 games with really outstanding results. What I'm going to show you is Demis Hassabis from DeepMind demonstrating the Atari game player, and it's missing balls now at the beginning of its training period. And after 120 minutes of training, you'll see it playing at a mediocre human level. Look at the score, not very exciting. But after 240 minutes of training, watch what happens. The system tunnels up the left-hand side of the screen and plays from the back court where the game has no defenses. Look at the score. Yeah. So that was a breakthrough not just in breakout, but in AI. And some people describe AI as a game-changing technology, like that's the highest possible praise you could deliver. But no, it's actually disrupting the entire playing field of the game. Most of you have heard about the win of the AlphaGo player against the world champion in Go. And just for context, chess has an average number of alternative moves per turn of 35. Go has an average number of alternative moves per turn of over 200. And then it fans out from there with each turn. So you can imagine thinking ahead is unbelievably complex. It's epically complex. So this shocked members of the Go community, less so members of the AI community, although I'm sure some were surprised. So the AlphaGo player beat Lee Sedol, the then world champion in Go, and a week later, because of this AlphaGo shock, South Korea pledged $3 billion for AI R&D. One country, which was heretofore a minor player in AI R&D, pledging a huge amount so that they could be in the game. If you're interested in increasing your talent bench strength and you don't have the money to hire them all into your company, you can use a data science competition website called Kaggle, which allows you to post your data on the web and your problem and have 250 plus of the world's best data scientists compete to solve your problem cost effectively. And it can be done with relatively small amounts of money, $50,000 or $100,000. This is extraordinarily successful, and you'll hear from Jeremy Howard later. Jeremy is the former president of Kaggle. If you don't want to put your data out in the public domain, you can post your problem and have the data scientists that are at Experfy bid on the solution to your problem. And you can see how they're ranked and rated and how they did on prior work. And you can pick the ones you like the best and rank them and rate them and have them solve partial problems or whatever you need to increase the bench strength of your AI and data science talent. In the spirit of full disclosure, I'm an investor in this company that came out of the Harvard X community. Applications are another driving force. If you have a technology that doesn't have practical and cost-effective applications, you can't get traction economically. And in fact, governments and Fortune 1000 companies around the world have been sponsoring AI for decades. And I took a look at over 360 innovative applications of AI that were curated at the Innovative Applications of AI website. And here are the patterns that I found that they shared in common. It's not just better, faster, cheaper. It's different. AI allows us to expand the range of the possible, to do things that we just couldn't do before. And you may ask, well, where can we actually apply AI to our problems? Where is it going to really have some bang? And the answer is across your entire corporation or entity. In design, diagnosis, manufacturing and management, customer service, sales and configuration, and quality. I'm not guessing about these. There are many examples of great AI applications in this area. We don't have time to go through them now, but you can look them up at the IAAI website. IBM used Watson to trounce the two world champions in Jeopardy. Watson got more points than each champion separately and combined. So what we're seeing now is that IBM is moving Watson into all kinds of domains, virtually every domain that they can get a credible partner in. They want to move Watson into that domain as a problem-solving entity. And they've opened up the APIs of Watson to all of their potential partners, the application programming interfaces. IBM announced in 2014 that they were going to invest $1 billion in Watson technology, and they set up a $100 million venture fund for startup companies that were interested in using Watson as their platform. And if you're interested in tracking what's happening with Watson now, you can go to the Watson Developer Conference in San Francisco at the Innovation Hangar. It's taking place in November, and they're likely to have web streams and reports from that conference. And that can get you very up to date on the whole Watson ecosystem. We are going to extend our intelligence using assistant systems. And all of you have seen Siri, and you have experienced the fact that there's lots of hype around Siri. Apple says your wish is its command. They say it understands what you say and knows what you mean. But I used Siri on my way here. It didn't understand what I said or know what I meant. So there are lots of websites devoted to the mistakes that Siri makes. And it's getting better. But the thing to recognize is that this is an embryonic technology. Alphabet has their own system. It's called Assistant, also a conversational agent to get things done in the real world. Microsoft has Cortana. What they did with Cortana that was good is they built Cortana directly into their operating system. There's a system called Hound that operates on iOS and Android. Some people think it's better than Siri, Google Now, and Cortana. Jeff Bezos was at a code conference at the end of May, and he indicated that more than 1,000 people are now working on the Amazon Echo connected speaker and its agent Alexa. This system lives on my kitchen table. I get traffic briefings and weather briefings and news briefings from NPR and sports briefings, and it can control the lights in my house. So it's embryonic, but it's starting to become useful. Echo now has over 1,400 skills, and it's growing every week in skill set. Alphabet has their system called Alphabet Home, a connected speaker to compete with Echo. A company that was in stealth mode until very recently is Viv. Viv was started by Adam Chyer and friends, who were the architects of Siri. And Viv has an amazing ambition. the whole team wants to create intelligence as a utility like search or Wi-Fi or Bluetooth, a utility that allows you to have a problem-solving agent with you on your mobile device 7/24. And when the Viv team gave a demo in New York fairly recently, the press said, "Oh, great, it's Siri on steroids." But no, actually it's different. Viv allows you to delegate work to a computer. This is a change in paradigm. Computers are not just tools anymore. I've got lots of tools on my pegboard at home. I can't delegate work to any of them. And you can now actually delegate work to your assistant, and it can do a credible job for you. So AI is here now, not in the form of HAL from the movie 2001, but in terms of practical problem solving that delivers billions of dollars of value in industry and government. So I'm encouraging each of you to develop an application-oriented AI toolbox that you can use back at home, at your work, in your institutions. And if you'd like to see the range of the breadth and depth of the application areas, the startup companies that are in machine learning and AI, you can download this infographic from Jovan Zillis at Bloomberg. And if you Google Machine Intelligence 2.0, you can just download this infographic into your system. So a seventh area that's going to drive the AI revolution for better or for worse is responsibility. The outcomes of the AI revolution are not determined yet. We know it's a powerful technology, but how we use it will determine whether our quality of life genuinely goes up, which I think it will, or flattens out or goes in the other direction. So we're seeing that AI impacts human resources, that it enables human-machine teams, that it can augment humans, that it increases precision and productivity, that it powers discovery and prediction, that it can transform business models pretty radically, and it can alter the world's work landscapes really disruptively, like that disruptive game that I showed you. That playing field is what we're looking at now in human resources. And I think that that's a very big challenge. It's one that will create some jobs and it will destroy jobs. And what matters is the ratio between the two. And if the ratio is unfavorable, we're going to have to think very carefully about how to get people to adapt quickly and educate them as best we can. And for those people who can't adapt quickly, we're going to have to see about creating some kind of basic income for them. That's my opinion. AI is going to blow the roof off of education. Not just one laptop or slate computer per child, but one tutor per child or adult learner. A tutor that can model where the user is, where the learner is, and what the learner wants to learn, and it can get them there in a custom format. It's still pretty expensive to do, but we're seeing rapid evolution in the MOOC world, which doesn't do the same kind of one-on-one tutoring, from Coursera, Khan Academy, Udacity, and edX. That community has a big ecosystem around it, from the venture capital community, the nonprofit world, universities, and companies, and we will see an increasing move towards one-on-one tutoring. If anybody tells you that AI is all good or all bad, that the consequences will be uniform, they are cherry-picking the data. I invite you to the adult conversation that AI comes with trade-offs. Yes, faster, cheaper, better problem solving, but also job disruption and human identity change and risk amplification and some risk reduction as well. So a big issue going forward is going to be trust. Not just whether you trust your AIs, but whether eventually they trust you, or whether we trust each other to develop the technology responsibly. Here's an example of machine learning used for risk reduction. This is from Airbnb, and they have a machine learning system that calculates the risk of inviting somebody into your home that you probably shouldn't invite, or going to someone's home that you probably shouldn't go to. So they're using machine learning to reduce your risk. Elon Musk has been writing about some of the downside risks of AI for a while. He's attenuated that in recent months. But to Elon's credit, he was with us at a Future of AI conference in Puerto Rico, where Jan Tullen invited in 50 AI researchers, and we sat around for 3 days talking about how to reduce the risk of AI having unwanted effects. And we signed a letter that indicated that 4 areas were particularly important for AI R&D going forward: verification, validity, security, and control. And we can come back to this in the Q&A after Jeremy's talk. Elon also funded with Y Combinator a new entity called OpenAI to democratize access to AI. They've invested $1 billion in this new entity, and OpenAI has already created an OpenAI Gym, a toolkit for evaluating reinforcement learning programs. We are going to reverse engineer the brain eventually. We're going to build more and more powerful AIs, and I believe that responsible use of artificial intelligence requires us to demonstrate core human values, like we actually care about the biosphere and each other, and practice interdisciplinary education, because the world is a seamless whole. We made up the academic disciplines. We'll have to practice safety R&D in those 3 areas I mentioned to you before, and active citizenship, because we are all in this together. You may recognize this as the birthplace of Hewlett-Packard. Assuming 0 new technology breakthroughs, professional work, I think white-collar work, is ripe for disruption. Here's data scientists disrupting data science. A company called Newtonian has Eureka, the virtual data scientist, and it's an embryonic data scientist that attempts to accelerate the process of building models and extracting answers from them. The Oxford Martin School has a study called Technology at Work 2.0. The future is not what it used to be. They estimated that over the next 10 to 20 years, 47% of the US job force would be vulnerable to automation. Of course, it won't be uniform across the United States, and they also extended their study to areas outside the US and the developing world, and you can see that the numbers are much higher there. Thailand, 72%, China, 77%, Ethiopia, 85% vulnerability of jobs to AI and machine learning. So this is a real challenge. We're going to have to take this seriously going forward. The key to managing the benefits and risks of AI is to combine humans plus AIs plus good business practices and processes. We are going to build an intimate relationship with AIs and machine learning. We are going to have a true symbiosis of machine and human intelligence. Here are some practical, operational recommendations for you in all 7 areas that I covered. In capital, if you have small amounts of capital, you can create a startup company and innovate. If you have large amounts of capital, you can acquire a company and integrate that amazing technology, not just into your products and services, but into your underlying operations. In algorithms, you can use high-quality free software or any of the very powerful platforms that are out there, Sentient, Watson, Viv, and others. For hardware, you can use specialized hardware or your laptops. You can use graphical programming units, tensor programming units, deep learning, application-specific integrated circuits, neuromorphic ICs. There's lots of alternatives now. For data, I'm encouraging you to inventory all your data and selectively exploit it, to create priorities and exploit it. That's really worth doing. We'll have an application screening workshop later today to talk just about that one topic. For talent, you can crowdsource your data scientists if you don't have them in-house from Experfy and Kaggle, Topcoder, and others. For applications, you can embed machine learning and AI into your products and services, and in particular, to transform your internal operations. With regard to responsibility, it's not just a throwaway line. We really are going to have to pay attention to this in terms of security, empathy, ethics, policy, and eventually liability. It's very important to have a sense of perspective about AI and machine learning. I don't know of any photograph that gives better perspective than this photograph of Earth taken from Jupiter's orbit. The little dot inside the yellow ring is what Carl Sagan called the pale blue dot of Earth. That's where all of us live. That's where everyone you have ever loved lives. That's where everyone you've ever read about in human history has lived. And it should be obvious by now that we're all in this ride together, and we better act like it. Thank you very much.